All right, folks, welcome back to 1.2, part 2. And in this part, we're going to talk about finding domain and range from a graph. All right, we'll go through a bunch of examples where we're going to be looking at the pictures. So, example 5, list the domain and range of this function h of x equals, oh my gosh, x squared minus 1. This is the example that we finished off with in the previous video, right? X squared minus 1. All right, so how could we just look at a picture and tell whether or not our domain or range is restricted or whether it's all real numbers, okay? I'm going to add a few things to this graph. And in particular, I'm going to add an arrow head going up on this side and another arrow going up on this side. Okay, and so I want us to keep in mind that when we're thinking about a parabola, it actually keeps going out forever and ever and ever. It keeps getting wider and wider and wider. Okay, now to look at the domain, right? Let's go back to our colors. If I'm looking at the domain, what I tend to do is I start from the most negative value and I just kind of scan my way across, all right? I'm going side to side because I'm looking for the x values. Are there any x values that are missing from the picture? Okay. And I notice that as I go across, I see function everywhere. Okay. So what that means is our domain is from negative infinity to positive infinity. We don't have anything missing. But on the flip side, let's think about our range, right? How is it that we find our range? Now, instead of going side to side, I actually start from the bottom and I start scanning up. Are there any places where I don't see any function? And the answer is, I don't see anything down here. In fact, the smallest value I see for y is -1, right? That means our range starts at -1, includes -1, and keeps going up until infinity. Okay, so domain, we're scanning across, and range, we're scanning up. All right, let's try another example. Number 6, find the domain and range of the function f. All right, now unlike the other one, this one does not have arrows. We have an open circle here, and we have a closed circle here. Okay, so what we see is literally what we get. All right, let's start scanning for our domain. I'm going to start at -3, and I'm going to go this way. I realize that I stop at an x value of 1, right? But let's talk a little bit about these open circles and closed circles. This open circle at -3 means that we don't actually include -3. Instead, we have parentheses -3. But by the time we get to x equals 1, we have a closed circle. So for 1, we're going to have a bracket. All right, so open circle does not include, closed circle does include. Now for the range, same thing. I'm going to start from the bottom and I'm going to scan my way up. And what y values do I see? And it looks like I've got -4 all the way up to 0. So everything is sandwiched in between there. So I'm going to go from -4 to 0, and I'm including both -4 and 0. Okay. All right, let's take a look at another example. Example 7, find the domain and range of g of x equals 2 minus 7x. All right, so we changed example 7. It is meant to be g of x equals the square root of 14 minus 7x, all right? But if we're looking for our domain, again, we want to sort of scan across this x-axis, but we realize that it stops right here at 2. Like there's no picture past 2. So the way we say that is from -infinity to 2, and we include 2. Okay. Now, as far as the range goes, I want to scan up the y-axis, right? And I realize the function starts at a y value of 0, but this is going to keep going up forever and ever and ever. So I start at 0, I include 0, and I go to infinity. Okay. All right, example 8 here. Got a little bit more of an interesting picture. Find the domain and range of f of x equals 2 plus x over x minus 5, right? And so this is going to be something, if you haven't seen this kind of graph before, we're actually going to take a look at these later on this summer, all right? But it turns out that there's a whole thing here that's happening, all right, that has to do with this denominator, x minus 5, right? So it's not a coincidence that this is x minus 5, and we have a problem at 5. But there's also another line that I think is important for us to highlight here, and that is that at 1, there's something going on, okay? And we'll talk about that later when we get to that unit about what's happening there and why. But for right now, I just want us to be aware there are some weird things happening. Now, if we think about domain and range, our domain, if we're scanning from left to right, the problem is going to be this purple part, okay? So it turns out that our domain is everything here and then everything here, but it's not right at x equals 5. Okay. So our domain, we would write from negative infinity to 5 in union with 5 to infinity. Now, if we apply similar reasoning for the range and we scan up, we might realize that this pink line is the problem when we scan up, and that pink line is at 1. So it turns out our range is everything up to 1 and then everything after 1. And so we write that negative infinity to 1 in union with 1 to infinity. All right. Last example here, let's take a look at example 9. We're going to find the domain and range of this function. And same thing, I will add those arrows onto the end just so that we know it goes in both directions forever and ever. And if we're thinking about our domain and range, our domain as we scan across, well, we've got a picture that keeps going in both directions. So we can say that is all real numbers, or from negative infinity to infinity. And then for our range, it might look like it's stuck between these two, but as it turns out, it does keep going up. It just gets really, really slow in going up, right? That means our range is also everything. It just takes a little bit longer to get to some of those really big positive values or really negative values. All right. And so, folks, that's it for part 2 here. I hope you'll come back for part 3, which is our last one for this section about piecewise functions.